Okay, so this is the last day of the benchmark review, part 4, and then I'll push the benchmark test out to you next week. And I think what we'll do is you'll have the whole week to get that test done. So rather than move into anything new next week, I'll give you the week to complete the test. So so the first one here we have find the value of x, and we have two similar quadrilaterals. They're laid out up here. Remember, the corresponding letters really matter, right? So when I look and I see that D corresponds to H, but I can also see in the picture from the way that it's labeled that they both have the same number of tick marks on them. Both have 4 tick marks. So I can set up my equation right from there. 4x has to be equal to 100 degrees. So I divide both sides by 4, and x would equal 25. Okay. Now I have a similar setup, ABCD, similar to PQRS. They give me AB, but if I want to use AB, I also would need PQ, and I do not have PQ anywhere. So I'm going to move on and look at BC. I have BC, so if I have BC, the two middle letters here, then I need QR, and I do have QR. So I can start off with, if I want the scale factor of ABCD to PQRS, BC, which is 6, comes from ABCD. So that scale factor is going to be 6 to 4. Or if we simplify that, 3 to 2. Okay, so you can write it as 3 to 2, or you can write 3 and a colon and a 2. Either one of those are okay for that. Okay. Next one, I have a 5-foot tall student who casts a 4-foot shadow. So I have the actual height in the top, right? So this is height, and then we have shadow is the ratio that I set up. Okay, so the height to the shadow is 5 to 4. Now I have a tree that casts a 44-foot shadow. So I want to know what x is. So you could cross multiply, or we can just see 4 times 11 gets us to 44. So x would have to be 55 feet here. If you wanted to cross multiply, if that makes more sense, 5 times 44 is 220. So I set that equal to 4x, and I divide, and I still get the same answer of 55. So even easier than similar triangles is when we have our parallel lines and proportional parts. We're trying to find the length of BE, so I'm just going to label that as my x here. So since I have parallel lines cutting those segments, then that ratio of 12 to 10 has to be equal to the ratio of 3 to x. So we can just cross multiply, and I have 12x equals 30. Try that again. I have 12 over 10 equals 3 to x, and that's my x is EB. So I have 12x equals 30, and then I'm going to divide by 12. So 30 divided by 12, I get x equals 2.5, and that's what BE is. BE would equal 2.5 in that spot. Okay, so here I have two similar triangles, FGH, PQR. I know that FG is 6 and PQ is 10, so that's going to be my scale factor of FGH to PQR. That's their ratio, 6 to 10. They tell me the perimeter, so this is FGH to PQR, 6 over 10. So PQR's perimeter is 35. He has to live down in the denominator. So I have 10x equals 6 times 35. That's 210. And then divide both sides by 10. So that perimeter would be 21. Okay. And the last one here, I want to find KL. So that's this one here. We'll call that x. So I can just set up a proportion of x to 28. Set that equal to 3 to 12. Okay, so if we cross multiply, I have 12x equals 84, and then I just divide both sides by 12, and I get x equals 7. And that should make sense there. 7 over 28 is 1/4, and so is 3/12 is also 1/4.